Let's take a simple example. The example we're going to take is a bunch of locations and the duration of travel time between these locations. And so our network is going to consist of locations, and our edges are going to consist of paths between these locations, and the edges are going to have a weight. The weight on the edge is the duration that it takes to go from place A to place B. So what we'll do is we will construct this network by going on to Google's Distance Matrix API to get travel times. Google's Distance Matrix API is what it gives you is you give it a bunch of origins and a bunch of destinations, and it returns a matrix, somewhat like in an old road map. When you get at the bottom, it tells you the distance between pairs of cities in the that are reflected in that map. So what this does is it gives us the duration or travel time or whatever information we want. The distance, for example, the Distance Matrix API can give us lots of stuff there between any two pairs of locations in this stuff, and we get a matrix with the in our case, the origins and the destinations are going to be the same, so we're going to get a cross matrix really. So we will use what we will use is to the Distance Matrix API takes latitudes and longitudes for each location, and so we're going to use the function that we wrote way back in class 3 and we used last week as well to figure out the latitudes and longitudes of each location in our network, right? So that we'll just walk through that. We've done that so often now that it's not really that great. So we can do that and see if it runs. Yep, we get latitude, longitude for New York, New York. So now we look at the locations that we have here. So the locations we have here are all around Columbia University. So we've got a bunch of places. So we have Columbia University as our first location, a bar called Amity Hall Uptown on Amsterdam Avenue as a second location, Ellington in the Park, that's a restaurant in Riverside Park, Chai Wali, that's a restaurant in Manhattan, that's like a bit of distance from here, but it's there. Grant's Tomb, that's a location that is where General Ulysses S. Grant, President of the United States and a Civil War general, is buried. Pastici is another restaurant. Nicholas Roerich Museum is a museum near Columbia that has paintings by Nicholas Roerich, who was an artist who painted a lot of scenes in the Himalayas. And Audubon Terrace, which is a historical building in New York, and Apollo Theater, which is a well-known theater in Harlem. So these are our locations, and so what we want to do, of course, is we want to be able to get all the locations for these, all the latitudes and longitudes for these locations. So we can do that by using our getLatLong function, and we run that, and it gives us a list of the latitudes and longitudes of our locations, right? So we've got all this stuff here. So next, what we want to do is, so this I've put this in this format here because this is the format that Google's Distance Matrix API expects for its latitudes and longitudes, right? So that's why it's come in this format where I've done this stuff there. Okay. So now you want to do the Distance Matrix API. So the API itself has this URL, and the URL has a bunch of origins and a bunch of destinations. And in our case, the origins and destinations are the same. So we say origins equals, add the list of latitudes, longitudes, and then the destinations equals, and add the list of latitudes, longitudes. And Google's Distance Matrix API will give us the data depending upon whether we want to walk, drive, or cycle. And I believe if you pay for it, you can also get through public transportation. So we're going to get the walking distance because these are all within walking distance of Columbia. And so we set the mode equals walking and add this to the API URL, and we get this as our URL, right? So this has a bunch of origins, a bunch of destinations, it has the mode and walking, and that's pretty much it, right? And the API itself, of course, is this one here, Distance Matrix API, and we're going to get our results back in JSON format. So we can get this stuff here, and we can construct a graph out of it. So what we do is we go to the to Google and here, and get the JSON version of the our result. So you can take a look at what the result looks like. So if I run this, I get the result looks something like this. So we can see that we've got destination addresses here, origin addresses over here, and maybe I make this bigger. Yeah, destination address is over here, origin address is here, and they're all the same, of course, because we're doing a cross thing here. And our data is sitting in the rows, and our goal here is to find the duration, which is this value at the bottom here, which is the number of seconds that it takes to get from one place to the other, right? So these are sitting in an array or in a list that contains all the cross information. So I'll leave that to you guys to figure out, but that's what we are pulling out over here, right? So we get the data from Google, and then we go through the JSON much like what we've done before and extract the value element from each cross duration. So the value element is this one here, and add that to so we have our nodes in our graph are going to be the addresses, the various addresses that we have, Amity Hall, Ellington in the Park, all that stuff. And we're going to get the edges are going to be from the origin, from one place to another place, and we add the duration, which is what we extract over here from the JSON file, and put that in a variable called D. You can give any name you want to that. This is the name that the network is going to use for that edge, for the edge weight, for the value in that edge. I've used D because it will show up nicer on the graph, but if you have better rendering, you can use a more descriptive name. You probably call it duration, but we'll see the graph, because our space is limited, we don't want to be taking up a lot of room with names, really. And then we can draw the graph itself. So let's do that, and we get the graph here, right? This is what it looks like. So what we want to do, of course, is, as always, is we want to functionalize this so we can reuse it if necessary. So let's make that function and call it over here. The function basically just does exactly what we did before, and we can test the function by drawing it with node and edge labels, and we print all the edges, and that's what this is doing. It's telling us multiple edges here. The star in this tells us that there's more than one thing in it. The star is what's called the unpacking operator. It's unpacking the list of edges so that we get them all one by one. And this is the edges we have in our graph, right? And it tells us, for example, that to go from Amity Hall uptown to Chai Valley and Lenox Avenue, it'll take you 799 seconds of walking. Okay, that's the goal there. So that's that. And now we can iterate through the nodes just to check everything, and we get through the edges to get all the edges. We got that too. And next we can draw the graph with our labels. So let's draw this, and we'll talk about it a little bit in a second. So here what we're doing is, let me draw it first actually.